Hi, today we're just going to quickly go over how to solve some of these problems in the last pages of our homework. For the first page and some of the questions a little bit uh, in the front of this is a little bit easier. So we're tackling some of the reasoning questions so you can answer your quick check and also tonight's problem. So we're going to be doing reasoning question number 5 and D, which is a multi-step equation problem. So let's take a look at reasoning 5. There are 3 points A, B, C exist in space such that B is between A and C. So we wanted to create a diagram. So number one, we wanted to draw a diagram. And then to create the situation so that we need to draw the 3 points A, B, and C. So a lot of you are probably inclined to draw A, B, and C on a line right here. But what if B is between A and C, but not necessarily falling right between A and C so that all three of them form the same line? So I wanted to kind of mimic that situation. If B is kind of like above or below A and C, so not exactly on the same line as A and C. So what is this situation? First of all, let's answer the question. We're going to skip the numbers for a moment. Are points A, B, and C collinear? To answer the question is that no. A, B, and C does not have to be collinear. Again, this word collinear, oops, I wrote too fast and misspelled. Very quickly, let's correct that. Collinear. Now, this word basically means together on the same line. So obviously that's not the situation. So because if I connect the dots right here, I can see that AC is on the same line. AB is not on the same line of the AC. And then BC is not on the same line, right? It's three separate and different lines. So A, B, and C does not have to be collinear. Could they be? Yes, they could. I could put a B right over here, or anywhere along this line of AC, but it's not always the case. There's no indications in here that suffice that it has to be there. Now, let's fill in the numbers that they gave us. They say AB equals to 7, BC equals to 4, and AC equals to 9, such that this is the situation. Now, if you put in these numbers, it starts to make sense. Wait a minute. So AB plus BC is actually a number greater than AC. It's not the same. Again, let's write that down. AB plus BC does not equals to AC. Because if I write 7 plus 4, first of all, it does not equals to 9. What does that equals to? The number actually equals to 11, and 11 is not the same as 9. So this further proves that A, B, and C does not have a collinear relationship, because previously in the homework we read to be collinear, in order to be collinear or together at the same line, AB plus BC must equals to AC. So in another word, I need to have two numbers. The lengths of the two numbers must be equals to the sum of, the sum of those two numbers must be equals to the last line. That's when they're having a collinear relationship. So this is your entire feedback for question 5. Now, in addition, we're going to also answer problem EG. Question number EG and all the others basically just use that relationship of collinearity and place that in problem solving such as algebra. I think it's pretty self-explanatory with the sections right here. You can just add them all up and set equals to the whole thing and basically solve for x. Add up the 3, solve for equals to the last one, solve for x, because the last one is the whole line. I think it got a little bit more complicated with C and D, where you have sections of lines not given to us, but a combination of some of the sections, right? So let's work on D. I think D is most complicated. We're not going to solve the equations right here. If you need help solving the equations, please stay in the class and ask us to help you solve the problem. But right here, what we wanted to do, more importantly, is kind of to come up with the equation that helps us first of all, and we will end our video at that point so you can work on it. So we wanted to take a look at the segments that's given to us. First, we have FG is equals to this piece 14 plus X. It's really helpful having a couple of highlighters around. And then we have the whole entire segment given to us as EG. That's 26 plus X. And then we have the next segment given to us is from F to H. FH is 12. Last but not least, we have EG that is given to us from E to G. It is X plus 23. It is really a great practice for us to list out all the things on the side. FG is equals to 14 plus X. The whole thing, EH is known to us as 26 plus X. And then FG, this helps us to stay organized. FH, it is 12. And then the last piece is EG is X plus 23. Now, it is really great to list it out because we might be using it later for substitution purposes. But now let's make sense of what is being given to us. So I have a piece that is given to me, the only piece that is standalone. So I don't know anything about EF. I don't know anything about GH, but that's all I know. There's multiple ways of solving it because I was provided with many additional pieces of information. But what I do know is that for the section that is given to me, which is 12, that little section plus what is from E to G, that section, if I add those together, it looks like it is more than the whole thing. The whole thing is 26 plus X, right? But so how much is more than the whole thing? If you overlap these two, it looks like the whole thing that it overlaps is exactly FG. So it's funny that how FG is just the overlap of the yellow plus the green. So in another word, if I wanted to write that into my understanding, it's like if I have the green plus the yellow, it is going to equal to the whole segment. I did not color it, so it's left in blank, the whole segment, plus, well, how much more, right? The orange piece. Now, the orange piece is FG, right? The yellow piece is FH. And then we have the EG, which is the green section. I try to color code it for everybody right here on the side so that we can fill in. So again, FG is the orange piece right here. I could fill it in 14 plus X. And then the EH is 26 plus X. The FH is 12. And then the EG is X plus 23. Again, this whole thing is when I add EG with FH, I kept saying that wrong, is really equals to the whole segment, EH, and a little bit more. How much more? The orange piece, FG. So that's how we come up with the equation. And once you have this equation, then it's very simple because all you have to do is combine like terms, combine the like terms, and then solve for the equation as how we do algebra in Algebra 1. So I'm going to leave it right here and let you solve for the answer of the question. Just remember one thing, that these two questions, C and D, it did not just ask you for finding X, but it asked you to find EG. So finding EG would then be our very last step. Please make sure that not only you, step number 1, solve for X by setting up the equation, that step 2, you wanted to find what the question is asking for, which is EG. Now, since EG is equals to x plus 23, you know that after you find the x from the last step, make sure you substitute it into this number, plus 23. You'll be able to get your final answer of what exactly is EG. All right, happy solving. You guys are doing great. Bye.